Hello guys, let's talk about oxidation reduction reactions and oxidation numbers. So oxidation reduction or redox reactions are reactions in which the oxidation states of atoms are changed, okay? So these reactions are characterized by actual or formal transfer of electrons between chemical species. Now, the oxidation numbers are simply used for bookkeeping to keep track of the electrons. Where does the electron go? Okay, we have a couple of rules to assign oxidation numbers. So first of all, if you have an element by itself, it's going to have an oxidation number of 0. Monatomic ions going to have the oxidation number the same as their ion charge. Group 1A metals going to have a +1. Group 2A are going to have a +2 oxidation number. Group 7A nonmetals or halogens are usually -1, but they can be positive when they are bonded with oxygen. Hydrogen is usually +1 with nonmetals and -1 with metals. Oxygen is usually -2. However, it can be -1 in peroxide, such as hydrogen peroxide. And the two very important rules: the sum of the oxidation numbers for a neutral compound equals to 0, and the sum of the oxidation numbers for a polyatomic ion equals to the ion charge. Okay, let's take a look at a couple of examples. So let's start with sodium. So which rule can we use to assign the oxidation number for sodium? The first one, right? This is an element by itself, so the oxidation number is going to be 0. The oxidation numbers are written above the element, so I can add that this is 0. Okay, what about S8? What rule would you use? The same one, right? Because it's the same element, it's simply sulfur by itself. So the oxidation number is again 0. Okay, how about chloride ions? Cl minus. What is this? Do we have a rule for it? We do, right? So this is a monoatomic ion, so the oxidation number will be same as the ion charge. We know that the ion charge is -1, so the oxidation number is going to be -1 also. Now remember that when we are giving charges, we give the charge first the number and then the sign plus or minus. In oxidation numbers, first you give the sign plus or minus and then the number. I hope this makes sense. Okay, let's move on to the next one, hydrochloric acid or HCl. Do we have a rule for hydrogen? We do, right? So hydrogen is +1 with nonmetals. Is chlorine a nonmetal? It is, right? So above hydrogen, we can write a +1. Do we have a rule for chlorine? We do, right? So chlorine is a halogen, so it is in group 7A, and it's usually going to have an oxidation number of -1, so we can add the -1 above chlorine. Notice that if you add +1 with -1, the sum is going to equal to 0, as hydrochloric acid is indeed a neutral compound, and the sum of the oxidation numbers in neutral compounds equals to 0. Okay, let's move on to the next example. Do we have a rule for sulfur? We don't, right? So we have to figure that out somehow. Do we have a rule for chlorine? We do, right? We just use this. So chlorine is usually -1 unless it's bonded with oxygen. But in this case, there is no oxygen in the compound. So chlorine is going to be -1. Let's call the oxidation number of sulfur X, okay? So if we add to X 2 times the oxidation number of chlorine, which is -1, the sum should give us a 0 because this is a neutral compound. So from here, we can solve for x. X plus minus 2 equals to 0. So x should equal to how much? Plus 2, right? So we simply figured out what is the oxidation number of sulfur. Okay, let's move on to the next compound, the sulfate ion. So, do we have a rule for sulfur? No, we do not. It did not magically appear. So now let's take a look at oxygen. Do we have a rule for oxygen? We do, right? So oxygen is usually minus 2. So I'm going to add the minus 2 above the oxygen atom. And I know that if I have a polyatomic ion, the sum of oxidation numbers should equal to the ion charge. So again, I can say that the oxidation number of sulfur is X. So if X plus 4 times minus 2 should equal to the ion charge, which is minus 2 again. So x plus minus 8 equals to minus 2. So how much is my x? It's plus 6, right? Do you see that in our first compound, sulfur had the oxidation number of plus 2, and now it's having an oxidation number of plus 6? So it is changing. That's why we do not have a rule for sulfur. Okay, let's move on. Let's look at hydrosulfuric acid. Do we have a rule for hydrogen? Yes, we do. It is plus 1 with nonmetals, and we know that this is a neutral compound. So again, we can say that we are going to assign the sulfur's oxidation number as X. So if I have 2 times, because I have 2 hydrogen atoms, plus 1 plus X, the sum should give me 0 because I have a neutral compound. So plus 2 plus X equals to 0. So what is the oxidation number of sulfur in this case? Minus 2, right? Okay, let's do a sulfuric acid. So let's start with hydrogen first. Hydrogen is plus 1 from the rules. Oxygen is minus 2 also from the rules. And we know that this is a neutral compound. So if we say that the oxidation number of sulfur is X, if I have 2 times plus 1 plus X plus 4 times minus 2, I should get a sum of 0. So again, 2 times plus 1 is just plus 2 plus x plus 4 times minus 2 is minus 8 should equal to 0. So what is my x here? X actually equals to plus 6. It is indeed the same oxidation number as sulfur had in the sulfate ion, right? Plus 6 was here and then plus 6 here again. So when you figure out the oxidation number of an element in a polyatomic ion, it's not going to change when that polyatomic ion makes a compound with hydrogen or any positively charged other ions. Okay, so let's take a look at our last example on this slide. Sodium sulfite. So sodium is actually an alkali metal, so it is in group 1A. We know that it's going to have the charge of plus 1. Oxygen is minus 2, so sulfur, let's say that is going to be X. So 2 times plus 1, right? Because we have 2 sodium atoms plus X plus 3 times, because I have 3 oxygen atoms, minus 2 should equal to 0, right? Okay, from here 2 times plus 1 is just plus 2 plus x plus minus 6, which is coming from the 3 times minus 2 equals to 0. So what is my x in this case? It is indeed plus 4. Okay, you can see the sulfur can have a different range of oxidation numbers. Okay, so now let's move back and talk more about oxidation reduction reactions. First of all, we said that in an oxidation reduction reactions, atoms are going to exchange with electrons, so the oxidation numbers are going to be changed also. So how about in this reaction when we have sodium solid reacting with chlorine gas producing sodium chloride solid? What is the oxidation number of sodium in this case? Is zero, right? Since it is an element by itself. How about Cl2? It is an element again by itself, so it's going to have an oxidation number of zero. How about sodium in sodium chloride? It is a group 1A metal, so this is going to be +1. How about chlorine? It is going to be -1, right? So based on the rules that we discussed on the previous slides. So what happened to sodium? Sodium actually went from 0 to +1, right? So it actually lost electrons. And then chlorine went from 0 to -1, so it actually gained electrons. Now here's a fun acronym. Leo, the lion, says Gear. So Leo, loss of electrons, is oxidation. Gear, gain of electrons, is reduction. So which process is oxidation? Which process did we lose electrons? In case of sodium, right? So this is going to be called oxidation. And in the process where we gained electrons is called reduction. You can write out these processes using the so-called half reactions. Let me show you. So the oxidation is going to be two sodium atoms producing two Na plus ions plus two electrons. So this is oxidation because we are losing electrons. And then the reduction side is Cl2 plus two electrons. Those are the same electrons the sodium atoms lost. Now we are adding them to chlorine to form two chloride ions. So here we have the oxidation and the reduction. Okay, there is a trick. Actually, sodium is being oxidized by chlorine. So in this case, Cl2 is going to be called oxidizing agent. Okay, now on the same token, because chlorine is being reduced by sodium, Na is going to be called the reducing agent. So I know it might be confusing for the first time, but in the process where you have oxidation, you are losing electrons. The substance or the atoms that are being oxidized are going to be the reducing agents because they are making the other atoms to be reduced. Now, in the reduction, you are actually going to gain electrons, okay, here, and the atoms that are being reduced are going to be the oxidizing agents because they are making the other atoms to be oxidized. Okay, I hope this makes sense. Practice these type of problems and it's gonna go easy for you. And don't forget, Leo the lion says gear. Leo is loss of electrons oxidation. Gear is gain of electrons reductions. See you in the next video.